Good evening, Daniel. How you doing tonight? Hi, Mega. Can you guys see the desktop okay? Well, welcome. Before we begin, does either of you have any questions? Okay, very good. A little bit later, I'll go over some anecdotes. Are there any questions on Chapter 15 security that we did last Thursday? Okay. How's the team project coming? Good. Yeah, you might get that. Very good, Daniel. I did check the teams again, and you're not in Team 1, right? Neither of you? No, okay. Yeah, what I'm doing now is checking to see if anybody withdrew. So I would let you guys know. As far as the role, everybody's still apparently in. They may not physically withdraw from the class, you know what I mean, but they might just not do any more work. That's happened. So if you don't get anything from that particular person, once again, you don't have to worry about it. Let's see, it's due on the 25th. So we're 7, 8, 9, 10, 11, 12 days away. So yeah, that you should be, I would think by the end of this week, you should have a draft being able to review from people. Okay? All right. Whatever they have is what they have. Are you communicating all right in your group? Except for 1 or 2 people? Great. Very good. Yeah, I see on the discussion, I get updates, but you may not be using the discussion board to communicate. Okay, the next thing I wanted to mention, the CC Confer question will be on Thursday. How are the final questions coming? They're due this weekend. I have questions from Chapter 1, 3, 4, 5, 7, 9, 10, and 11. I don't have any from 2, 6, 8, 12, 14, and 15. So I'm just encouraging you guys, if you're, let me look at that. Let me see the chapter to students. So I'm sure Bayo is doing questions. He's usually on. This isn't you, right, Daniel? Right. I think you've done yours, right, Daniel? Yeah, chapter 9. Yeah, I thought so. Hi, Steve. Hi, Karen. I know Shu Lin is active, so I would assume that she would be giving, or he would be giving the questions. And Fawad, I think he might have. I've only checked to see what's been turned in. Yeah, I thought he might have. Just a note for those people that aren't on tonight. Credit you can make up to a C if you have less than 32 points on your tests. Send me an email that you'd like to make up to at least a C, and I'll send you back a number of questions to answer from the book, and you can earn up to a C on those. But these also have to be turned in by the 25th, which is, once again, 12 days from tonight. Are any of you going to be doing the extra credit programming project? No. Okay. That's fine. Last year I had 2 students do it. I think I shared those with you earlier. Okay, well, let's talk about tonight. It's going to be pretty brief because what I really would like is to have you guys work on the project. So I kind of left week 10 and 11 open. See, there's not much on 10. It's just a CC confer question. There's no homework or anything like that. And then 11, same thing. Just submit the team project. And I expect just the leaders to submit their team's project here. So I'm expecting 5 submittals. Okay, I'll just go through the anecdotal things. Typically, compilers can do absolute addresses in addition to relative and virtual. For example, BIOS startup physical address is at a certain location in memory. The IRQs running in memory have physical addresses, okay, typically through a certain address, depending on the operating system. Relative addresses are offset from base registers, which we've talked about, and virtual addresses, which we've talked about, dynamic address translation. The compilers can do absolute, relative, and virtual. They can do all of those types of addresses. I talked about this last time, asymmetric algorithms. You take the original document, you encrypt it using the receiver of that document's public key, send the encrypted message to the receiver. The receiver would decrypt the message using their private key. And I illustrated that with the program last time. I wanted to talk about a tape story with you guys. And it was important to me, so let me kind of describe it. Back when I first started in 1977, I joined a company called State Insurance. Might have been Ocean State Insurance. So it was an insurance company. It's so long ago I can't even remember. And I was the manager there of IT. I was an IT manager. And I was responsible, my first programming experience. The only reason I got the job was they were offering a minuscule amount of money, and I wanted to break in, and they were willing to train me on submitting jobs and stuff. So I was responsible for running the computer programs at CUC, which was Computer Usage Corporation in Sunnyvale. I doubt it's there anymore. But it was an IBM. They had an IBM 370 running OSBS1, which was the first virtual storage on the 370. Okay. Let's see what else about this. On that IBM, they were using JCL, Job Control Language, and I was learning that. Okay, and that JCL had a job card. You started off with a job card. Then you had step cards that actually ran programs. So you would have a step card that said program equal whatever, and it would run that program. And then underneath that particular card, you had data definition statements that described the disk or tape that program would be using. And what we're coming to is the tape. Okay, it was 9-track tape back then, and there were two different speeds of these tapes. One was 1600 DPI, and that's bytes per inch. And then the newer one was 6250 bytes per inch. It's called DPI, bytes per inch. And it looked like this on tape. I was going to try and illustrate this. You had a reflector spot on the tape. There's a reflector spot, and that is when it's hit. It has two of them. It has the beginning of the tape and the end of tape. It had these reflector spots. Okay, and the data would be the reading-writing device. Reading-writing would occur after the tape mark. So it kind of, as soon as it hits the tape mark, then you can read and write blocks of data. Okay, and it used blocks. So blocks would be like, I would have 80 character records. Back then, that's what they used, because there were 80 characters on a key punch tape, a key punch card. So 8 blocks of 80 character card images, and they were usually buffered by 20. So it would be 1600 bytes per block, and that's what would get written to the tape, are these blocks. And the logical records are the 20 logical records per physical block. This concept is still used today, guys. So now we need to look at what happens. So when the operating system wants to start writing a file, it puts what's called a tape mark on the tape. Okay? And then if it has, there's three methods. They were called standard labels, or it could be no label. So if it has standard labels, it would have two 80-character label records, that were 80 characters each, that describe what number. So like if it was the first file on this tape, right, that would be file 1 in those two records. Then it would put another tape mark. Okay. So if it had standard labels, it would have two records, then a tape mark, and then the data. The data would follow. At the end of the data, it would put a tape mark. Okay. And it would have some closing data. So if it was no label, then it would have another tape mark. If it was standard labels, it would have the end. So it would have the end of standard label mark. Okay. And I forgot how many records that was. And then another tape mark. And then if this was the last volume, it would have an end of volume mark. Okay, and that would end of volume mark on that. So that's kind of what a tape looked like from a program perspective. Now, if you look at the physical device, let's do a couple. Let's do a couple of bytes here. That's 8 bytes, 8 bits. So that's 1 byte. So if you imagine a bunch of read-write heads, there would be 9 of them on a 9-track tape. In other words, there would be a track for this bit, there'd be a track for this bit, a track for this bit. So each one has a read-write head. And finally, it would have a parity bit. That's why the 9. 8 bits and a parity bit. I'm not going to calculate the parity, but it was either even or odd parity. And that would represent 1 byte. So the data would look like that when you copy it on the tape. So let me paste a few of these things. And then let's get a byte here. Because when we're going this way, we're going down the data. Okay, so there's 1 byte of the data. Here's the 2nd byte, the 3rd byte, the 4th byte, etc. So it's reading 8 at a time, comparing it to make sure that that's correct. And then at the end of that block, it writes a block. So some kind of a block device. And that would be at 1600 bytes. So 1600 of these. So now, is this clear as to how the tape is getting written to? Or read from? Okay. What I was learning was that these standard labels, I could put a series of files using standard labels for file 1, file 2, file 3, file 4, file 5, and I could save the company $2 a month for the tape storage. And I was thinking, hey, I was pretty smart. I could do this, right? So I did that for the company's, let me think a second. Once a month, I would go and run the company's finance, and the insurance would be, we put out all the premiums, that's how much money we got in, and then all the claims, that's how much money we put out, and all of that information would be on these tapes. So I'd have 1 month, and then the second month, the third month, the fourth month, the fifth month on one tape. So I was probably in the job maybe 10 months after I started this, for I guess the third month or so. So I had like 5 months of data on the tape. And the operator ran out to me and said, I can't load your tape. And I said, what do you mean you can't load the tape? Because I was going to read the fifth block that's on the tape, or the fifth file on the tape for the fifth month. And he said, yeah, I've tried several times, but when I looked at the tape, the reflector spot fell off the tape. And every time I try to paste it over where it looks like it's pasted, I can't get the start of the tape mark here that the computer puts on there. All right, and he said to me this. He said, if you were using 1600 BPI, there's 3/4 of an inch between the tape mark, the reflector spot, and the tape mark that starts that tape. But when we move to the 6250, there's 1/8 of an inch, and I can't find that right 1/8 of an inch spot to put the reflector spot in order to get to the tape mark. So basically, I was very screwed at this point. So all kinds of thoughts went through my mind that I was really in trouble. So what do you think I did? Besides freak out. Any ideas? I wouldn't be here today if this wasn't resolved. No, you couldn't. You couldn't, because you couldn't get to the start of the tape. It's a good guess. No, what I did is I went to the systems programmer at CUC, and I said, I really need help. I got a tape here that the reflector spot fell off the front, and I can't read this sucker. And he said to me, oh, are you using standard labels? And I said, yes. And he said, no problem. What I'll do is read to the end of volume marker, which you could do, and read the blocks backward from that, so the tape would actually roll back a block, roll back a block, roll back a block. And you ever watch a tape, they go in one way, but they can also back up. So what would happen would be, it would back up a block, read that block, back up 2 blocks, read that block, back up another 2 blocks, read that block. And so he read the blocks backwards. He said, do you want me to sort them or just give them to you? And I said, well, I can sort them if you can give me the blocks. So I got all the data blocks in reverse order from all the files and immediately put them on separate tapes. And that saved my job and my career. And I learned about how tapes really work. So I got this thing up from 9-track tape from Wikipedia, and it kind of explains how the tapes work and the different density levels of the tape. And it mentions the reflector spot in here. See the sensing of the BOT and the EOT was achieved by shining a small lamp at the tape surface at an elliptical angle. When the foil strip glued to the tape, and that was the key thing, it wasn't glued to my tape, moved past the lamp, a photoreceptor would see the reflector and then trigger the system to either halt the tape or start reading the tape if it's at the beginning of the tape. And this was the main reason that photography, flash cameras, were not allowed in data centers, since they could trigger, and they did, trick the tape drives into falsely sensing that they have an EOT or a BOT. I never knew why, you know, when I was in the data center, that they said no cameras. Well, this was why. Okay. I told you that story. Is there anything you guys want to discuss? If in that case, I'm going to say let's call it an evening. I want you to work on your projects, though. That's why we're giving you this time. Thursday will probably be a short night as well, unless there's questions. Well, on the yeah, Steve, on the deliverable, let's look at that again. I believe that the amount of detail that you have should fit between 5 and 6 pages per deliverable. I mean, that's probably the best I could say in terms of detail. Yeah, 5 to 6 pages for each deliverable is optimum. You could do more, you could do a little less. It just depends. You may want to go into one topic. Oh, you mean finding information. That depends on the operating system. What are you doing? Well, the current Mac OS, right, is kind of based loosely on Unix So I would look there. I'm not sure how much you can get from Apple. They're pretty closed. Let's see. What are you doing? What's deliverable? And I guess there's zero here. You're doing it for a PC, right? I'm just looking at one paper here. And this looks interesting. You could pull information from here, right? So, it's out there. Remember, if you pull anything out of this, you need to quote it. If you pull it directly out of this, you need to quote it and reference it. Does it have to? It doesn't have to in my mind. We're talking pretty general as well, right? Let me look at that again. Doesn't it differ from phone and PC? Some of the routines are different, yes. I don't know in terms of process management how different that is on the phone versus the PC. Let's go back and see if we can see that. I'm stuck here. I hate that when they redirect me like that. Yeah, it doesn't say. You'd have to read the article and find out. Yeah, you could be. I'm not sure what you guys are doing. What team are you on? 3. I have Unix for you guys. Did you change it to Mac OS? You're on Team 4. Okay. Yeah. This is you, right? That's okay. Yeah, I don't care which version of the Mac OS, as long as all of you are doing the same one, right? I think I'm getting another group is doing Mac. I guess it's Team 2. I see that one of these teams is doing the Sierra build. Okay, and it might be Team 5. I'm not sure. It might be Team 2. So whatever version you guys are using, that's fine for me. And like I said, if you want to target a laptop device, or you want to target a let's see, what have we got? An iPad, right? Or an iPhone, if that's your targeted device, I'm okay with that. As long as all of you do the same one. I just think it's real difficult to pull a lot of detailed information from these. Finding it's kind of tough. As you can see, I mean, I'm looking, and this stuff is like the OS X operating system was one of their first, Mac's first foray into his OS X, and that was 8 years ago, maybe even 10 years ago. Okay. Yeah, I'm not going to be able to give you much direction on this one, other than I believe that you guys as a team have to decide what you're doing. What's your targeted environment? Is it the iPhone? Is it an iPad? Is it a PC? What's the operating system environment? You know, the hardware. Okay? I know it's kind of hazy, but I want to leave it open for you to have some room. I don't want to, lock it up for you or your team. Okay. Any other questions about the project? Let me check something while I've got you guys here. 2 years ago, what was this one? This team did Linux. And I can't remember what kind of a grade I gave them, because I don't mark on this the grades. I just keep there some middles. And this team looks like they only had 5 people. So it says user interface was assigned, but they dropped the boss. No, I don't post any samples. I don't want to post samples. I show and illustrate samples here, but I'm not going to post them. Let's see, process management. Let's see how big process management was, so we get some idea. So this one starts at 9 and ends at 14, so it's 5 pages. So this person's processor management is 5 pages, and that's about right. Other questions? Well, it should. Hang on. That's a good question. It should definitely show 0 points. Because that would affect the grades. I gotta fix that. Glad you caught that. Yeah, what I typically do though is I pull them out and I put them in Excel, and then I do my own totals. So I probably would have caught it then, but let's take care of it now. Okay. Good. Thank you, Karen. Yeah, once again, when it went across from Catalyst to Canvas, in Canvas there's a special mark, and it obviously didn't take when it came across. That you mark it as not, I guess, as extra or optional or something like that in Catalyst, and I missed it. I'm glad you caught it. Speaking of extra credit, don't forget that the class evaluation, when you do that, that's Monday the 26th, 27th, and 28th. It's open those 3 days, and you can just submit an evaluation and get 10 points automatically. Okay? Okay, any other points? That was very good. All right then, I will say have a good evening, and we'll see you on Thursday. Thank you. Thank you all. Work on your projects. Have a good evening. Thank you. Oh, hi, Kang. I missed you.